exercise 3 here as well. Maybe have a practical exercise, we could say. It's about temperature. X hours after midnight, the temperature is given by the function which you see here, second degree function. And here we have it. And we should calculate t of 1. T of 1, we just put 1 into the function and we get this. So we get 1 minus 6 plus 15, which of course is 10. So t of 1 is equals to 10. And what a function works like this. We put something in and we then chew like a gum and then we spit something out. Right? And we have to know what is it we're putting in and what is that we're spitting out here. And spit x in. No, we put x in, that's the hours after midnight. So this is 1 o'clock, and out comes the temperature. So this means that at 1 o'clock, the temperature is 10 degrees. And if I put 4 into the function, I will get the temperature at 4 o'clock, which will be this, which is 16 minus 24 plus 15, which is 20. No, sorry. This is not 23, it's 7. 7. So at 4 o'clock, it's a bit colder than at 1 o'clock, it's 7 degrees outside. Then we should find t, the derivative of t when x is 1. So we have to find the derivative, just move down here. And I get 2x minus 6, right? And then I find the derivative when x is equals to 2. So I get 2 times 1 minus 6, which is minus 4. We get the negative answer. And the derivative tells us, it's also called a gradient function or Stenstal-function. It tells us how fast something is changing in a given point. And here we said 1 o'clock. What this told us, the first question was that at 1 o'clock, the temperature was 10 degrees. But the derivative when x is 1, that's the gradient of the tangent line at 1 o'clock. And that is minus 4, which means that the temperature is decreasing at a rate of 4 degrees per x, and x is hours, 4 degrees per hour. So the temperature is decreasing at exactly 1 o'clock. The temperature is decreasing, and it's decreasing by 4 degrees per hour. But if we put 4 into the derivative, we find the rate of change at 4 o'clock, and then we see we get a positive answer. That's because at 4 o'clock, the temperature is rising, and it's rising at a rate of change which is 2 degrees per hour, right? So this tells me that at 4 o'clock, it is 7 degrees outside. But this tells me that the temperature is increasing since I get a positive answer, and it's also telling me how fast it's increasing at exactly 4 o'clock. It's increasing with a rate of change of 2 degrees per hour. And then we should check that if this function has 0 points, which means does it actually cross the x-axis? Doesn't look like it with my figure here, but that's just a sketch here. So I have to find out, if I want to find 0 points, I of course put this function equals to 0. So I put this equals to 0 and use the ABC formula. Then I will get minus b plus minus b squared minus 4 times a times c divided by 2 times a. And I get 6 plus minus here. I get 2 here. But under the square root sign, I get 36 minus 60, which is minus 24. This will be 60, and this is 36. 36 minus 16 is minus 24, which is, we can't take the square root of a negative number, which means we have no solution, which means that the temperature will never be 0. So probably in the summer or in the spring, this midnight thing here, right? So never 0. So the answer is no. It doesn't have any 0 points. And then we would find any maximum or minimum points here. And remember, this is a second degree function, so we don't have to use the derivative. We could use the derivative, of course, put the derivative equals to 0, and then draw sine lines and so on and so on. But since it is a second degree function, this is a second degree function, we know that the x coordinate of the minimum or maximum points is minus b times 2a. But of course, if you want, you can use the derivative. So x is then equals to minus, and b here is minus 6 divided by 2 times a, and a is 1. So I get minus is plus 6 divided by 2, which is 3. So we have a minimum or maximum point when x is equals to 3. But remember, this is a parabola. It's either like this or like this. But the term in x squared is positive, which means it's smiling. It's not like this. It's like this. So this is a minimum point. But I, of course, also have to find the y coordinate, and I put the x coordinate into the function, and I will get this answer here, which is 9 minus 18 plus 15, which will be minus 9 plus 15 is 6. So the y coordinate is 6. So that's the minimum point, which means that the temperature is at its lowest at 3 o'clock. 3 o'clock, temperature is at its lowest, then it's only 6 degrees outside. So that was what the answer tells us. So that was